Okay, so today we're just reviewing. If you have any homework type questions, I can answer them. And also, if you have any tests or pre-exam 4 test questions, I'll answer those. So the Mojia, some students have asked for an extra copy of that. It's been posted on Blackboard. So I'm going to, instead of printing them off, because I don't know how useful it will be on this test, what I'll probably end up doing is put it on the, what is this called? I'll probably end up putting it up here. So I'll make it fit where it's large and you can see it. And that way, if you want the comfortability of it, it's there, but I don't have to print off 30 more copies of it.
Okay. Oh, yes, we just use ours.
If you don't have anything written on it, you can bring it. But if anything's written on it, you can print it off and bring a fresh copy. That's fine. But if anything's, nothing should be written on it.
Oh, you can't add the.
You can't add anything. Mm-mm. So, but honestly, it doesn't really come up that much on the exam, these formulas. I mean, some students just want to have them, so it's a safety thing and a comfort thing, but you don't apply a lot of them. It's pretty straightforward.
On the big test, so the ones you like, a lot of the ones that you supplied weren't even on. It was like
I know.
trapezoid one
Yeah.
that wasn't on here.
Yeah. So it a little bit is if you think of it as cutting it into 2 triangles or something like that. If the trapezoid. Yeah, so I mean, most of the Math 128 student or instructors don't give you anything for this test, but I thought since we are, trying to prepare you to take the Mojia for majority of you guys, not everyone in here will take it. I thought I'd just give you this if needed, but and circumference will come up or area will come up. If you don't have that formula memorized, it'll be up here, but I don't know how handy. I mean, it really just can you find the radius and plug it in your calculator correctly. So there's that. Yeah, you should know kind of the process of it. Instead of memorizing formula and just plugging it in, know the process. Area, length times width, right? So if I break it up into squares, I can find the area of any shape. Surface area is going to be the surface area of all the different sides. So a lot of times students will try to remember, I don't even think surface area here, a lot of times students will try to memorize this formula or they'll try to apply this formula, but they forget what they're doing. They're taking the area of the front, the area of the back, the area of the left side, the right side, and the top and the bottom. Top and bottom are the same, left and right are the same, and front and back are the same. So that's where the 2 comes from. So Blackboard also has the answer key to the pre-exam posted. So yeah, it just got posted today. So you should be able to go through and convince yourself you did those correctly. Some of them are just, identifying. And this is just kind of a sample exam part of it. It's pretty straightforward. If you want to go to your book and look at the last part of your book, in Chapter 10 review. Now keep in mind we didn't do all the sections in Chapter 10. We stopped at 10.6. If you look at your textbook, any of the homework type problems are free game. So even if they're even or odd, if it's around that section, we didn't do 10.7. So if you go to the summary, it gives you, 10.1, what the summary is, 10.2, 10.3, all the way through 10.6. Gives you a review exercise. So These are free game, or things like this are free game for the test. Identify the triangle as acute, obtuse, or right, or then equilateral, isosceles, or scaling. So 10-3, the type of questions you have in 10-3, 10-4, 10-5, 10-6, and then of course we didn't do 10-7. So the chapter tests, these are a good way to kind of test yourself. The answers are in the back of the book to all of the problems, right? I think you have the answers to the chapter test, all of them. So here's, 26 questions. That gives you, well, keep in mind we didn't do the last couple problems because that was from 10-7. We didn't do 10-7. So anything with tessellations or things like that, we didn't cover. But all these types of stuff is free game. So if you want more things to study, you can come here and kind of look at what could be asked. Does anyone have any questions on the written homework that's due today? Question.
For 10-5, like you gave us a list of surface area like stuff, but on like number 25 and 29, they're triangles. What?
So last time someone asked this exact question for 25 and 29, and we're looking for surface area. So looking at the figure from before, we have to find surface area and we have to come up with lateral height. So the surface area, which wasn't given, which was in your book, for these shapes are, let's see, what do we give here? Area of the base times the lateral surface area for 25, and pi r squared plus pi rl for 29. So you have to find the area of the base for 25, and then take that times the lateral height. So in any kind of cone or shape or pyramid, you have two different types of ways you can talk about the height. You can talk about from the base of the shape, the perpendicular distance to the top. That's the height, that's h. And then there's the lateral height. If I was to run up this pyramid, what was the distance I would run? That's this distance here, kind of. And that's denoted as L in your book. So for the surface area of a pyramid, the formula was base, area of the base, in this case, why can I not spell area? Area base times L. No, that would not give you surface area, sorry. That would give you, what do we do here? 1/2.
No, it's like
Is it 1/3?
Yeah, what?
Times height. Or
Oh, here,
base
sorry.
height.
That's why. We didn't look at the formula. The surface area is the area of the base plus the area of each side. There's 4 sides here, and those sides are triangles with the height being the L, right? So we have that the base, the area of the base is calculated. Then I find the area of the sides of the triangle, which if I cut off one of the sides here, it has a base of 6 and a height of h, but instead of calling it h, your book calls it L. Right? Or if I cut this is still h here, and it's given as 4. So you have to calculate L. Right? If I take this triangle here, that gives me the height of the side of the triangle. We talked about this one in class a couple days ago. So to find surface area, you break it down to find what is the area of each surface. There's 4 surfaces here. The base is a square, and then there's 3 faces of the pyramid 4 surfaces. Sorry, there's 5 total surfaces. 4 surfaces of the pyramid. They're all triangles. Area of a triangle is 1/2 base times height, right? 1/2 the base of the triangle times the height. The height here is not given. You have to find it, which you have to use Pythagorean theorem to find that. And it's represented as L here. Turns out the lateral height is 5. So the area of each triangle is 1/2 the base of the triangle times the lateral height. There turns out to be 4 of them. So if I multiply that by 4, I get 60. There's one base, which is 6 by 6. So to find the surface area of the base, I take base times height, and I get 36. I add those 5 sides together, 4 plus 5, or 4 plus 1, and I get the total surface area. (29), the surface area is still going to be the area of the base plus the lateral sides, the surface area of the lateral sides. The surface area of the lateral sides here are pi RL. The area of the base, pi r squared, plus pi RL. So the same thing here, you're given the height of this cone, and you need to find the lateral surface area. So you have to find L. To calculate L, you look at this triangle and use Pythagorean theorem to come up with 17. So then you plug it in the formula, or you say, okay, area of the base, pi r squared, calculate that, plus the lateral area, which is pi RL, multiply that together, add them together, and you get your answer. Anything's free game like this. This is obviously a higher level one, but there will be a surface area problem.
Yeah.
Whether it's a
Everything else is fine besides the triangle type.
yeah, so triangle is just one extra step because you have to calculate L. You have to calculate a missing piece. In rectangulars or squares, obviously they give you the 3 dimensions, so you don't have to calculate anything before you can find the surface area. We look at some of these here. Surface area is going to be straightforward, right? I'm going to take this area plus the top plus the bottom plus the back side and the left side, right? It's the same concept in these types of problems, except the surface area, you have to use Pythagorean theorem to find the lateral distance. And then the surface area here is area of the base plus 4 times the area of one of the sides. Same thing here. Here, the surface area of the top plus the area of the bottom plus the lateral surface area, which is still length times width, or base times height. But here, the base is the circumference of the circle, and the height is given as 32. It doesn't matter which orientation it is. If it's laying up or down, the surface area is, you're going to calculate them the same. And then surface area of a sphere is pretty straightforward. And volume of a sphere, those might be on your formulas for sphere. Volume of a sphere and surface area of a sphere. So here you're just plugging in R. So there's nothing to calculate. They're really boring problems. Here's a sphere, here's its radius, find its surface area. You're plugging R into the formula. Same thing with volume. You're plugging R into the formula. There's nothing you have to calculate or anything. You just plug what R is. Maybe the highest level problem I could give you there is give you the diameter of the sphere. Then you can calculate the radius. But then again, if it's a 10-point problem and you don't find the radius before you plug in diameter, you plug in the diameter, should I give you partial credit for that? Because the formulas are on the board.
Considering the fact that we're doing it.
Yeah, considering the fact that's what majority of students that mess up that problem do. So I want to be able to give you some level of, you have to do some steps if it's going to be worth 10 points. And a lot of this starts out as classification. What is this? A line, acute angle, obtuse angle, a right angle? an equilateral triangle, a scalene triangle, a parallelogram, a rectangle, dodecagon, quadrilateral, things like that. They're all 1-point problems. It's really hard to kind of gauge what level you know the material at.
Isn't it dodecagon 10 sides?
12.
Miss Van Ryn,
Yes.
are you gonna give us those formulas?
They're going to be, either I'll print them off for you because 1,500 people asked me, or I'll put them on the board like this,
Okay.
where everyone can see. Equation of the line, slope of the line, you don't really use. But, well, that's what I was thinking. I might just, instead of printing it off for everyone, just post it up here. But.
You could accidentally have answers up there. That'd be really cool.
Any other questions on the homework?
I have a question.
Okay.
Number 41 and 45 on 10.6.
10, 6, 41, and 45.
And then I was wondering if we could do one for this.
Yeah. So let's look at 41 first. We have, how high is the satellite radio tower? If the angle of elevation from the ground is 82 degrees and the observation point is 700 meters from the base of the tower. So we have, this person is looking up at this tower, and the base of the tower is 700 meters away. And he's looking up at an elevation from the ground of 82 degrees. And we want to know, how high is the satellite radio tower? So majority of the word problems is, can you draw a picture? If you can draw a picture, then it simplifies to, here's a triangle, find the missing piece. So how am I going to calculate for x? What do I have here? It would be tangent because I have opposite and I have adjacent. So what is my relationship? If I say tangent of the angle, which is 82 degrees, is going to equal x over 700. So if I put this in a ratio, and if I want to solve for x, I cross multiply. So x is going to be 700 times tangent of 82. I don't know if my calculator does tangent. So 82, and I take tangent of that. I'm going to make sure I'm in degrees. Take that times 700. And that gives me, yeah, we'll say 4,981 meters.
Also another question.
Mhm.
On the test, the triangles, are they going to be already labeled like A, B, C?
Maybe not.
Okay.
No. So if you look at some of the homework in this section, it might just be like this. And you have to draw your triangle and put in your missing pieces and find what it wants. So here it just wants side A. Here it might want side B, might want side C, just depending on what's given. So it might be up to you to draw this triangle, put in what you know, and find what's missing. And that's really all you're doing on this problem here. You're drawing the triangle, you're labeling what you know, you're labeling what you want to know, what you want to find, and then using the right trig function to find that.
But C is always gonna be the right angle, right?
C is always the 90-degree angle, yes. And opposite of that is always the hypotenuse. So it will give you, it could give you two sides and ask for an angle, right? So like 27 here, find angle A if side B is 183 feet and side C is 275 feet, right? So if I draw this picture, I have a triangle, This is C. Let's call this A and call this B. This is little a, little b. We know little b is 183. And we know little c is 275. And I want angle A. What do I need to use to find the measure of angle A?
Inverse adjacent over hypotenuse. So, so cosine?
Yes. So if I say, so what this is saying, cosine of A would equal over 275. So if I wanted to find what A was, I plug in my calculator cosine inverse of 183 over 275. That would give me my angle measurement. I'm not sure if my calculator has inverses. They don't. Oh, wait, there it is. No, that's hyperbolic. So 183 over 275 cosine inverse. You have to be comfortable with your calculator. Some calculators, you can push the cosine inverse button and it gives you a parentheses. You put what's in parentheses, close parentheses, and enter. Other calculators, you have to put what's in parentheses first, enter, then hit your cosine inverse button.
I don't know if I did it right, but I got 48.28279.367.
That sounds reasonable.
48.
If you get anything over 90 degrees, well, you won't. You won't ever get anything over 90 degrees.
So it really like matters that the B is on the opposite side of the
Yes, yes. It matters where you put it because this B, what they're calling B, is the side opposite of the angle B. What they're calling A is the side opposite of the angle A. So your first step is to draw your triangle correctly and put the corresponding parts correctly. Then the second step is actually using the right trigonometric function to get the angle. But if you're looking for an angle, you're going to use your inverse buttons. If you're looking for a side, you're going to use your sine, cosine, and tangent because you're going to be given an angle. And then the other question was on 45. We have a treadmill that has a 6 feet long, has adjustable back leg so that the edge can be anywhere between 0 to 8 inches lower than the front. So we have kind of this setup here. Find the range of angle at which this model can be inclined. 6 feet long, so this is 6 feet and this is 6 feet. Back leg so that the edge can be anywhere from 0 to 8 inches lower than the front. All right, so you need to find, obviously if it's 0 inches lower than the front, the angle is 0 degrees, right? So I want to find what's the maximum angle this can be to get me to be 8 inches above the front, right? That's the highest I can go, 8 inches. So here, what am I going to use? Wait, I want to kind of fix this here. Let me see what I want here. This is 6 and this is 8. And I want the angle. So cosine inverse of 8 over 6. Let me go to 28, third edition. This is 10. 6. And this is number, what number was it? 45. It's in inches? Oh, sorry. Yeah, you would be signed. Is it in inches? And this is in feet. So you have to be very careful with that. I didn't pay too much attention. Inches and feet. So you need to convert this to, you need to convert this to inches first. So this is 6 feet, which is 72 inches. And this is 8 inches. So it's sine, let's call this A. Sine of A would be 8 over 72. So if I take sine inverse of 8 over 72, it would give me the angle. So your angle is going to range from 0 to 6.4 degrees. Make sense?
Yeah.
Any other questions?
I have a question on the pretest.
Okay. So let's look at the pretest.
No, I have one.
Okay. What's your question? What number?
Number 10,
Okay.
it's a proportional property
Mhm.
of similar triangles.
Yeah.
So, I mean, they give us that CD is 24.
Mhm.
We know that 8 times 3 is 24. So
Mhm.
I want to multiply 12 by 3, which is 36.
But be careful, the whole distance is 36.
Right, so that's my question. I have to subtract the 12.
Yes. If you want to find x.
That's what I didn't do, so I would have got all that wrong.
Well, of course you wouldn't get all of it wrong because you're along the right.
So when it's proportional, find out what we need to multiply it by, but make sure you subtract.
Depends on how it's set up. So this whole thing, right, is going to be
36.
the relationship. Yeah. And I just want x.
How'd you find out that it was 36?
Well, she said if I go 8 over 24, to get 24, I take 3 times 8, right? So if I say 12 over what, well, it's going to be also times 3.
Oh.
But that's going to be this whole distance.
And we only want X?
We only want x.
Yeah, when it said that, I guess I would think it wanted everything. But if it wanted everything, would it say A through D?
Yeah, it could say A through D if it wanted everything. But x is just this distance.
X is just between E and D.
Mm-hmm.
And see, I'm afraid I'm going to get confused on what it's actually wanting. It just says X.
Yeah, if it says find the measure of x.
Oh, and then it says, if I would have read the parentheses, the measure of ED is X.
It says, yeah, find the measure of x, which is ED.
Okay. All right.
Right.
I think I can handle that.
So if we get to, oops. I thought I printed the answers.
Okay. I have a question.
Okay, go ahead with your question.
My question is for the 24. On the pretest.
Number 24.
The last one.
So,
It's like a tree which is 93 feet tall, casts a shadow of 80
Yes.
feet, and find the angle of elevation of the sun.
so the angle of elevation of the sun to the nearest degree. So the first thing you want to do is draw a picture. We have a tree. Oops, not a person. We have a tree. Maybe it's a Christmas tree. And it casts a shadow of 83 feet. This is 83 feet. I want to know the height of the tree. No, it gives the height. The height of the tree is 93 feet. And I want to know the angle of elevation of the sun round to the nearest degree. So this is kind of tricky the way you set this up. The angle of elevation of the sun is going to be this angle here.
So the other one is
Well, this would be the angle of elevation from the person looking up to the tree. This is the angle of depression. which is actually equal to this, because parallel lines cut by transversal alternating interior angles are congruent. Let's see what I did on here. Yeah, so you have to be careful with the wording. Angle of elevation, it should really say angle of depression.
Oh, really?
And this is where I think I pulled this from a different book, and they use different wording here. Angle of elevation. If this is the sun, right, and it's coming in here at this angle, if I have a parallel line, angle of depression, this would be the same angle here. Because these are all, if this is parallel and this is parallel, alternating interior angles are going to be congruent. If you would have given me the other angle, it's fine. I'm not going to be too picky. Angle of elevation or angle of depression.
I thought elevation meant going up, so I was
Mhm.
saying like if I'm at that shadow and I'm looking up towards the sun, I'm measuring that angle right there above the, to the left of the.
Yeah, so that's a proper way to look at it, but it gets confusing. If you're the person looking up at the same, that's the angle of elevation of the sun. If you're the sun, the sun's angle is an angle of depression.
Right. The sun's looking
Yeah.
down, shining down.
So, yeah, the angle of elevation of the sun from your point of view. So I'll try to be very careful the way I do that on the exam. If I say from the sun's point of view, angle of depression, or from your point of view, angle of elevation.
Right.
So if you're looking up at the end of the shadow and you're looking up at the sun, what's the angle that the sun's at of its elevation? But if you're on the sun, or if you want to know this relative to the sun, it would be the angle of depression. It's the same angle though. You're going to calculate it the same way because they're congruent.
What do they call it? Interior.
Alternating interior, but it also turns out angle of elevation and angle of depression are complementary. In every right triangle, they're complementary because they're going to add up to be 90 degrees.
Right.
This angle plus this angle has to be 90 degrees. So angle of elevation and angle of depression are complementary angles when you're talking about, and that's the one thing in trig it can get tricky because you can be looking at angle A, someone else can be looking at angle B and do total different calculations and get the same answer. You can have cosine of 17 and they could have sine of the complement of 17, you're going to get the same answer. So there's more than one way to look at it. Here, what is the trigonometric ratio I would use to find this angle?
Inverse tan.
Yeah, inverse tangent, right? I would plug in tangent inverse of 93 over 83, and I would get the angle.
That was my question. You have 48 and somehow I got 54.
In my answer,
And I set it up exactly that way.
and you plugged in 93 over 83. I don't have an inverse button on this. Someone do tangent inverse of 83 over, or 93 over 83.
It's like I get 48 and then whenever I push enter on my calculator it equals, then it jumps to 54. So I don't know which one is right.
So on your calculator, do you hit tangent inverse first?
Last.
Okay, so you're typing 93 divided by 83, enter. And what do you get? You should get something less than
Like one.
yeah.
One.
Yeah. So then you hit second tangent inverse.
And it comes up 48.25, but then whenever I enter, it jumps to 56.
So when you're entering, yeah, I should. Yeah. Anyone have any other questions on your homework or your take-home test? Yes? 20 on the take-home test? So let's look at number 20. So 20, okay, you guys, if you're gonna leave, get out of here. So we're gonna go over number 20. If you're gonna stay and want number 20. Okay, so here, this is gonna be a multi-step problem. First, we're gonna have to find what we need. We might need volume, we might need surface area, and then we're gonna have to convert that to how many gallons we'll need to buy. Chemical company needs to paint 30 chemical tanks, including the top and bottom of each tank. Each tank has a height of 10 foot and a diameter of 6 feet. So we have these tanks. Height of 8 feet and a diameter. Be careful, they give us diameter, not radius. Paint can be purchased in 1 gallon cans or 5 gallon cans, and the cost is the same as 4 1 gallon cans. So we're gonna have to keep that in mind when we have to go to buy them. Each gallon of paint will cover 350 square feet. How many of each should be purchased to keep the cost of paint in the tank as low as possible? So I need the surface area because I'm painting, right? And the formula or the process of finding surface area is pi r squared would be the area of the base, plus pi r squared is the area of the top, and it says we're painting the top and the bottom, plus 2 pi r h, right? That would be the lateral surface.
How do you know when to find surface, or when to use surface area?
Well, if you're painting something, that's surface area.
You're just painting the surface.
Yeah.
You just care about the surface, not the inside.
Yeah, you're not filling it up, because filling it up would be the volume.
So here on our note sheet.
I guess my question is,
Mhm.
how did you know that it was a tank that wasn't like that?
And that's
Because I kept wanting to do like a rounded end tank.
Mm-hmm. You want to do like a square one? So yeah,
Or like just like rounded, not, you know, not equal, but like rounded. Like
oh, so you're like a top of a tank,
Yes.
like a silo. So there's formulas for those types of things, but this one's like, it should have probably said a right circular cylinder. So you know, yeah, it will on the test. If there's, I just copy these from the textbook, and that's right out of the textbook. So turns out if we go to calculate this, keep in mind R is going to be 3. So this is actually 2 pi 3 squared plus 2 pi 3 8. If I plug this in, go back to this, I end up with feet, and then I also know that I'm getting 30 of them. So there's 30 chemical tanks that I need to paint. So I take this times 30, and that's going to be my total surface area for 30 tanks. Then that gives me,
Do you want us to use the no pilot and just use 3.14?
that's fine. Yeah, you can use your pi button with 3.14. It's going to be a close enough number. It's not going to matter. Your book wants you to use 3.14 because you're looking at the back for answers, and that's the number they use. If you use your pi button or use 3.14 and you've got the right answer, I'm going to give you the points for it. So let's just look at walking through this process. So 350 feet squared, I'll need to buy a gallon. So if I divide by 350, it tells me I need 17.76 gallons. So I can't buy a half a gallon or a 0.76 of a gallon. So I have to buy 18 gallons. Then I think of what's the cheapest way to buy 18 gallons. Well, for every 5 gallons, if I buy it in a 5-gallon bucket, I save the price. It's getting like a price, yeah, for free. So I can buy 5, 10, 15. Then I can either buy another 5-gallon bucket and have 20 gallons and have extra, or I can buy it by the 1 gallon. And here, I mean, this is just kind of saying, if I'm buying more than 5 gallons, more than 4 gallons, it's going to be cheaper to buy 5 gallons. Here I only need to buy 3 gallons though. 3 gallons is cheaper than buying 4 gallons.
What did you do after you got 30?
After I multiplied by the 30, I got this number here.
So if we do the 253 squared plus
Mhm.
that equals 207.
Then I multiply by 30 tanks because there's 30 tanks I need to cover. So each tank is going to need less than a gallon because for every 1 gallon I can paint 350 feet squared. So if I take how many total feet squared I need for the 30 tanks, divide that by 350, it's going to tell me how many gallons I need. And you have to round up because we have to buy enough paint. So I need to buy 18 gallons. And then I play the game of how do I need to buy those gallons? I can buy 1 gallon. I could buy 18 1 gallons, but that's going to cost me more money because I save a little bit if I buy the 5 gallons. So I'm going to buy in multiples of 5 until it's cheaper to buy 1 gallons. So 5, 10, 15, because I need 15 for sure. Do I need 20? I don't need 20 gallons. I only need 18. If I needed 19 gallons, it would be the same price to buy the 20 gallons. But I only need 18, so it's actually cheaper just to buy 3 1-gallon things of paint.
I think this problem, like you just had to go slow with it.
Yeah, it incorporates a lot. First off, you know how to write a right circular cylinder, even though they don't tell you that. Second, knowing the surface area, which I don't know if surface area of a right circular cylinder is on your sheet. It is. So you can use your sheet, plug in R, because an H, and that's both given.
Yeah.
So then you come up with the total surface area of 1 tank, multiply that by 30. You get the total surface area you need to paint. Divide that by how much 1 gallon will paint, and that's how many gallons you need to buy. And then you play the game of how do I need to buy them. Be careful, there's a problem like 19 if it says surface area or if it says volume. The surface area is like the one we talked about in the homework at the beginning of class. Volume of a rectangular solid, pretty straightforward. If it said volume and surface area problem is pretty straightforward too. Circumference, know the difference between radius and diameter?
You only need to find 106.76.
What?
Oh, no.
It asks for 2 things here. It says the circumference and the area. On the test, I will have a place for circumference and a place for area if I ask for both of them.
Oh, I didn't even notice that it needed area as well.
Yeah, so on the test, a lot of times I break it down and say, I'll have like a surface underline and then I'll have circumference underline and you'll have 2 places. Same thing here, I could ask for the surface area or I could just ask for the volume.
It's pi r squared, that one.
Area?
For area, yes.
Area is pi r squared. Perimeter. Here we have a perimeter minus 3 feet opening, so pretty straightforward. Perimeter. The ratios, here we had to solve for the missing piece.
For the number 11, the sum of the measures of the
What is the sum of the measures of an angle of a triangle?
formula thing,
Huh?
like n minus 2, 180. Is it just one?
It's n minus 2 times 180. So in a triangle, n is 3. So 3 minus 2 is 1 times 180. If I say, what's the sum of the measures of an angles in a hexagon or pentagon, you have hexagon has 6 sides, a pentagon has 5 sides, you plug it in that formula.
Oh, you plug it in that one.
So here for a triangle, the formula you can plug it in is 3. So n minus 2 times 180. Or you could just know the sum of the angles of triangle. Know the words complementary and supplementary. They might come up. I don't know if they come up in the pretest. Yeah. Know how to classify angles. So if I say, what are 1 and 4? Well, 4 and 5 are alternating, or sorry, if I say 1 and 4, those are vertical angles, which is not a choice here. Oh, no, it is right there, vertical. 1 and 4 are vertical. 1 and 5 are corresponding. 1 and 8 are alternating exterior. Right? So know those 4 terms: alternating interior, alternating exterior, corresponding, and vertical.
So corresponding would be like 1 and 5, 2 and 6.
Good, yes. 3 and 7, 4 and 8.
Vertical is what?
Vertical are 1 and 4, 2 and 3, 5 and 8.
The vertical are
Vertical mean that in the two, they have the same vertex. 2 lines, they have the same vertex.
okay.
They're kind of like opposite.
6 and 7, 5 and 8.
6 and 7, 5 and 8. Those are vertical angles.
Okay.
Vertical angles are congruent, right?
Uh-huh.
Alternating interior angles are congruent.
Yeah.
So 7, 6, 3, and 2 are all congruent. And there's different ways you can come about it. 2 and 6 are corresponding, so they're congruent. But 2 and 3 are also vertical, they're congruent. And 3 and 6 are alternating interior. So if 3 and 6 are congruent, then 2 and 6 have to be congruent because 2 is congruent to 3. So there's more than one ways to think about it. If I say, if I give you parallel lines cut by a transfer, if as long as I give you one angle, boom, you know the rest, right? You know them by vertical and supplementary. 1 and 3 are supplementary angles
Mm-hmm.
because they're a straight line,
Yeah, it's an equal to 180.
180 degrees. So if you know 1, you know 4. If you know 4, you know 5. If you know 5, you know 8. And then the rest of them, 2, 3, 6, and 7, you can find by knowing it's supplementary to 1. So classifying angles: acute, right, straight. 4 ways to name an angle. So, I mean, this test starts off pretty basic stuff, and then at the end, of course, it can get more complicated level of questions. Of course, time is a factor here, so I can't give you too many like this without it being worth quite a bit of points.
Oh, yeah, that
So-
would be forever.
Yeah. And this is a pretest, so I just try to give you a wide range of problems, but
And
yeah.
then it's interesting, like the one with the can that we're painting.
yeah,
That one had so many steps.
yeah,
Which is, there's more room for error on that than actually like your sign. cosine,
yeah, which
tangent.
there's more room for partial credit. So they're going to be worth more, right? So if you calculate the area wrong, but you go through and say the gallon's right, so maybe your area is off, but your gallon's right, and you come up with the right conclusion, you're going to get partial credit for that.
I remember last test, I was like, oh man, I'm close to like the end.
Yeah.
We gotta go, and I had like 2 more problems.
Yeah.
to look at.
Yeah, I mean, generally, this test has been shorter. I mean, a lot of it's calculation. The thing about the last test, it had a lot of calculation in it, so you wanted to be careful and check yourself, and so there's a lot of things to punch in your calculator. Here, there's hardly anything to punch in your calculator. You either know it or you don't.
Gotta plug it into the
It's
formula.
yeah, but even then, there's not a lot of those. So it's either you're gonna know all of it or not.
I'm feeling pretty good about this one.
So it's the last one till the
Yeah, I
final.
really wanna pull my B up, so a little bit
Mm.
higher. Something.